Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. So whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. So today we'll be solving chemistry paper 1A HL of time zone 2 and of the 2025 attempt. Let's get started with the first question. So it's section A. Yeah. So a test tube contains a mixture of liquid hydrocarbons. What is this type of mixture and the best method of separation? So when you have two liquids mixed with each other, it forms a homogeneous mixture, right? If you mix solid liquid, that's heterogeneous because you have two different mediums together in the mixture. But if you have two same liquids in one mixture or two same phase in a mixture, that would be homogeneous, right? So just make a note here. Hydrocarbons, they will definitely make a homogeneous mixture. Yeah, so I can eliminate option C, option D. Now, to separate homogeneous mixtures, right, we have to use distillation. That's the only way we can separate a homogeneous mixture. And we cannot use filtration because filtration is used to remove a solid from a liquid, right? Let's say you have sand water mixture, you can remove the sand from water using filtration. But if you have two liquids which are completely mixed with one another, you cannot use filtration. So you have to use distillation, which involves boiling points, right? So answer would be A. Next, which property is same for water containing tritium and water containing hydrogen? So tritium is heavier than hydrogen. So the masses will be different, right? So if masses are different, so obviously density has to be different. Yeah. So density cannot be the same. Molecular mass cannot be the same, right? And another thing is if you have higher mass, right, the London dispersion forces will be stronger. So London dispersion forces are stronger in tritium as compared to hydrogen. As a result, tritium will have a higher boiling point, right? So boiling point is also different. Only dipole moment will be same in tritium and hydrogen because it only involves the number of protons and electrons, not the number of neutrons. Okay. Now, moving to the next part, the maximum number of electrons that can occupy the n equals 3 mean shell. The formula for total number of electrons in a shell is 2n squared. So 2 times 3 squared, which is 2 times 9, giving us 18, which is option C. Next, what is the group number of the element whose successive ionization energies are shown? So here, yeah, they have shown us 10 ionizations, right? You can observe that after the first electron has been removed, there is a jump in the ionization energy, right? And this jump is quite a bit, right? Because here it is probably like 100 or 200, right? And this thing is, I think, around 20, around 3000. Yes. So it's a 15 time jump, right? And if you check, there is also another jump here, but this jump is not that massive because this thing is around 9000 and this thing is around 16,000, not even double. Yeah. So this is the ionization step. So there is only one electron in the outermost shell of this element. So the element should belong to the group one. Answer is A. Yeah. So this is a 15 jump. Well, this one is probably a 1.5x jump. Right. Next, we need to find the empirical formula of the compound with the following composition by mass. You have to find the moles of carbon. So we'll just assume the percentages to be as masses, right? The total mass is 100 grams. So mass of carbon will be 37.5, hydrogen will be 12.5 grams, and oxygen is 15 grams. Okay, so 37.5 divided by 12. This will give us 3.125 moles of hydrogen. This will be 12.5 divided by 1 gives us 12.5. Moles of oxygen would be 50 divided by 16 gives us 3.125 again, right? So we'll do carbon, moles of carbon is to moles of hydrogen is to moles of oxygen. We'll try to find the simplest whole number ratio of these moles. So 3.125 is to 12.5 is to 3.125 again. Now we'll divide all these numbers with the smallest number, which is 3.125. If I divide everything with 3.125, I'll get 1 is to 12.5 divided by 3.125 would be 4. And then 3.125 divided by 3.125 is 1 again. So carbon, it's 1, hydrogen is 4, oxygen is 1. So the empirical formula will be CH4O. Matches with option D. Now the next part. What is the charge on the monoatomic ion usually formed by the element with the following electronic configuration, right? So here this element has 2 plus 5, 7 electrons, right? 7 electron means the atomic number is 7, which is nitrogen, right? So yeah. So nitrogen generally forms N3 minus ion. You cannot, like, you'll never see nitrogen forming N plus 5 ion, right? Nitrogen generally gains 3 electrons to form N3 minus, which is the nitride ion, right? So answer would be option A. And nitrogen is also a non-metal, right? So it'll accept electrons, not it'll donate electrons. Next, which molecule is polar? So you have to find a molecule which is unsymmetric or which has lone pairs on the central atom. CH4 is completely symmetric. There are no lone pairs on carbon, right? It looks like this. I mean, CH4, sorry. It's symmetric about the carbon atom, has a tetrahedral shape, no lone pair on the central atom. So this is definitely not polar. C6H6 is benzene. In benzene also, this is a completely symmetric molecule. Yeah. As a result, there is no dipole moment. It becomes interesting with SO2. We can try CO2 first, like if you want to do elimination. CO2 looks like this. So it's completely symmetric about the carbon atom and there is no lone pairs on the central atom. So as a result, CO2 is also nonpolar. So we are left with SO2. But how do I prove that SO2 is a a polar molecule? You find the number of electron pairs around sulfur. This will be half. Sulfur has 6 valence electrons. There is no negative charge and no positive charge on sulfur, and there is no monovalent atoms attached to sulfur. Monovalent as in atoms which only form single bonds. Oxygen forms double bond with sulfur, so it's not monovalent. The number of electron pairs around sulfur should be 3. Number of lone pairs around sulfur. This will be number of electron pairs around sulfur minus the number of atoms surrounding sulfur. There is one lone pair on the sulfur atom, right? So SO2 looks like this. Because of the lone pair of the central atom, there will always be a dipole, and hence SO2 is your polar molecule. Next, we have to find the RF factor of this paper chromatogram, right? So RF is distance moved by your compound, which is 21, right? So compound moved 21 millimeter compared to the origin, right? Divided with the distance moved by the solvent. So solvent is 21 plus 7, so solvent moved 28 millimeters. And yeah, 21 divided by 28 is 0.75. Is 3 over 4 basically, right? Gives you option B. Now we have to find the electron and molecular geometries of XeCl4. XeCl4 will first start with our calculations, right? So number of electron pairs around Xe. This will be half of the number of valence electrons on xenon, which is 8 because xenon is a noble gas. There is no positive charge, no negative charge on the atom, on the molecule. And there are 4 monovalent atoms. Chlorine is monovalent because it forms single bond with xenon, right? Gives you 6. You have 6 electron pairs around xenon. And then we'll find the number of lone pairs around xenon, which will be number of electron pairs around xenon 6 minus the number of atoms attached to xenon, which is 4. There are 2 lone pairs around xenon, right? And number of electron pairs around xenon is 6. Now, from this information, that number of electron pairs around xenon is 6, I can say that the electron geometry for electron pairs around central atom 6 is octahedral. So electron geometry is octahedral. I can eliminate C and D, right? Now the molecular geometry or the shape. The shape goes like this, like in an octahedral electron geometry, you can place lone pairs only on the axial position, not the equatorial position, right? So XeCl4 will look like this. Okay. If you look at it, it looks like square planar, a square plane, right? So the molecular geometry will be square planar. Answer is B. We could have eliminated option A just by looking at the molecular geometry, because if your electron geometry is octahedral, your molecular geometry can never be tetrahedral. Okay. Next, we have to find hybridization around nitrogen, carbon, and oxygen. For hybridization, we just count the number of sigma bonds and the lone pairs on that atom. Okay. So for nitrogen, there are three sigma bonds, so three single bonds and one lone pair. Okay. Four means the hybridization is s and 3p orbitals, right? Carbon. Carbon, there is only three sigma bonds, right? One sigma bond in each of the single bonds and one in the double bond. So double bond has one sigma, one pi bond, right? So two sigma bonds in the two single bonds, one sigma bond is the double bond. It is three. Three means I can choose first three orbitals, which is s and 2p orbitals, sp2. Oxygen, two lone pairs. So I'll take two, and there is one sigma bond in the double bond. So two plus one again. I can just write one plus two. One is the sigma bond in the double bond. Two is the lone pair, the two lone pairs, right? So it gives you three again. So oxygen, again, you have to choose the first three orbitals, which is sp2. The nitrogen is sp3, carbon and oxygen both are sp2. Answer is option B. Question 11. We have to find which monomer actually produces this addition polymer. There is one CH3 group. Like generally, if you want to convert it to a monomer, just replace the central carbon-carbon bond as a double bond and remove these two bonds. Okay, so that's the change you need to apply. Now, from the option, we have to search which compound is this. So this is incorrect. Um, um, Wait. Let's start with the first one. This is incorrect, obviously, because you have two CH3 groups on two different carbon atoms. Okay. Here, B is incorrect because there are a total of four carbon atoms in the monomer. We have three, right? D is incorrect because you have two double bonds. There should only be one double bond. Now C is correct. C, if you check, one carbon has two hydrogen, the other carbon has one CH3, one hydrogen. Exactly matches with the structure of our monomer. So answer would be option C. Next, why do group 17 elements have higher first ionization energy than group 1 elements in the same period? Obviously, because group 17 elements have more nuclear charge or a bigger number of protons in the nucleus. Higher number of proton means the valence electrons will be held more tightly by these protons, and you need more energy to remove electrons from group 17, right? So for question 12, the answer would be option D directly. Okay, now. Which part of the periodic table contains elements which are likely to form acidic oxide? So, metals form basic oxides, right? Na2O is a basic oxide. Na2O mix it with water, you get NaOH. MgO, MgOH whole twice. CaO, CaOH whole twice. These are all bases, right? So metals form basic oxides. This entire thing will be basic oxide, okay? But non-metals form acidic oxide. Like for example, yeah. You can take NO2, right? Mix NO2 with water. NO2 is nitric oxide. It'll give you a mixture of HNO3 and HNO2. Both are acidic. So C would give us acidic oxides. Answer would be C. Now we have to find the oxidation state of nitrogen in N2O4. Take nitrogen as X. The two nitrogen atoms, so 2X, four oxygen atoms, and oxygen generally has an oxidation state of -2. So we'll take -2. 2X minus 8 is 0. 2X would be 8. Divide both sides with 2. You get X as 4. So answer would be +4. Yeah. Now, which properties are typical of transition elements? Transition elements are transition metals, right? So use the term metals here. So metals never have low melting points. They have very high melting points. So the first one is incorrect. When you can eliminate the first option, right? You can eliminate option A, option B, and option D. So you're left with option C. Also makes sense because like transition elements form colored compounds and transition elements have variable oxidation states, right? On to question 16. Yeah. Here you have to find the electronic configuration of Cr2 plus ion. So electronic configuration of Cr would be Ar 4s1 3d5. This is an exceptional electronic configuration. Is restricted to chromium and copper only, right? So Cr2 plus means I'll remove two electrons. So I'll remove the 4s1 electron, right? And I'll remove one electron from 3d5. So it becomes 3d4. So Ar 3d4 is the electronic configuration of Cr2 plus. Now next, which compound shows cis trans isomerism, right? If you look at A, right? So you just have two fluorine atoms on these carbon atoms, right? And the rest of it is a ring. Yeah. So there's only one possible orientation. You cannot have any other orientations for part A. So this cannot show cis-trans isomerism. Let's make a note here. Okay. Next, you also have hydrogen atoms connected to these carbons, right? So this cyclohexane ring can show both cis-trans configuration, right? If F is on the same side for both, then it's cis, and if F is on other sides, so or F is on opposite sides, it's trans. So answer would be B. Now we can also check C. For C, carbon 1 has hydrogen and hydrogen. Carbon 2 has fluorine and fluorine, right? So you should not have two identical substituents on any carbon for cis-trans isomerism. So C is wrong. You have identical groups on both of the carbon atoms, right? Now for option D, carbon 2 has hydrogen, fluorine, different substituents. Okay, that is carbon 1. And yeah, carbon 2 has both fluorine. So same substituent on one carbon. So cis-trans won't be possible. Now, moving on to question 18. You see, reactants have lower, it's a reaction where energy is absorbed, right? So products have more energy as compared to reactants. So products are less stable. More energy means less stability, right? So reactants are more stable than products. The answer would be either A or B. We can eliminate C and D first. Now, this energy was absorbed from the surroundings, right? The delta H enthalpy. The energy. Okay. So when we absorb energy from surroundings, what happens is the surroundings become cooler. So of course, temperature of the surroundings would decrease. Answer would be A. Reactants more stable, temperature decreases. In the next case, we have a calorimetry problem where we have to find the enthalpy of combustion, right? So we know the amount of fuel burned, mass of water, initial for final temperature, specific heat capacity. Let's find the heat absorbed by water. It will be mc delta T, right? Mass and if you check, C has grams here, so I can use grams as mass. So 200 times 4.18, delta T is final temperature minus initial temperature. If I feed this on a calculator, I'll get 3344 joules. Okay. And delta H will be negative Q over N. This is the enthalpy of combustion for the fuel. N is the moles, Q is the heat released. Okay, so minus 3344 divided by 0.11. Give you minus 30400 joules per mole. Divided with 1000, you'll get minus 30.4 kilojoules per mole. Answer would be option B. Now next we just have to balance this reaction and we have to report the coefficient of oxygen. So first I'll balance the carbon. So I should place a 2 in front of CO2, right? To balance hydrogen, there is 6 hydrogen on the left. Yeah. And just place a 3 in front of H2. We'll make 6 hydrogens, right? The number of oxygens on the right side will be 2 times 2, which is 4, and 3 higher oxygens on the H2. So you have 7 oxygen on the left side. On the right side, 1 oxygen is on C2H5OH. Though we need to add 6 more oxygen, so I can just place a 3 in front of O2, which will balance out this reaction. The answer would be C, which is C. Next, which change results in the least result in the decrease in entropy, right? So where entropy decreases. If liquid gets converted to gas, randomness increases. So delta S is positive in this case, not negative. A is incorrect. Solid is becoming aqueous. Again, if you're mixing solid in a liquid, right, the solid particles or the molecules can move freely in the liquid. So randomness increases. Delta S is again positive in this case. Next, MgCO3. MgCO3 is a solid, right? It forms MgO, which is a solid, and CO2 is a gas. Gas is produced from a solid. Randomness increases. Delta S again is positive. Can also be eliminated. But for the last one, right? You have 3 moles of gas on the left side, 2 moles of gas on the right side. So number of moles of gas decreases in this case, right? So in this case, your entropy is negative. Your randomness decreases as the moles of gas is decreasing. Answer would be D. Next, which value indicates an equilibrium reaction, which is delta G equals 0, right? Yeah. Next, we have to identify the limiting reactant theoretical yield of hydrogen. So we know the moles of magnesium and HCl. Let's identify the limiting reactant first. To find the limiting reactant, we have to do moles divided by stoichiometric coefficient for each of the reactant. For magnesium, moles is 0.2, stoichiometric coefficient is 1. For HCl, moles is again 0.2, stoichiometric coefficient is 2. Now, the one with a smaller ratio will be a limiting reactant. So we can say HCl is the limiting reactant. And we can eliminate option A, option B from here. Next, we have to find the theoretical yield of H2. So you have to find the moles of H2, right? Just write the molar ratio, moles of H2 by moles of HCl. Yeah, this will be 1 over 2. Correct. Then moles of HCl is known to us, which is 0.2. So moles of H2 will be 0.2 divided by 2 gives you 0.1. So HCl is the limiting reactant, and theoretical yield of H2 is 0.1. Answer is option D. Next, we have to find the units for rate constant. Rate constant is change in concentration over change in time. Okay, this is the formula for rate. Change in concentration means the unit of the numerator is concentration, which is mole per dm cubed, and unit for time is seconds. So the rate equation, the unit for rate should look like this. But instead of seconds, if it's a slow reaction, you can also have it in hours. So this is also a valid unit, right? Mole second cannot be the answer because it's missing like volume. Dm cube hour cannot be the answer, missing moles, right? Uh, Option C is correct. It's absolutely this one. Yeah. Option D is incorrect because S is in the numerator. Time should be in the denominator. Okay. So we can also eliminate D. Next, which changes increase the rate of the reaction? You have to make the reaction faster. So first, introducing a catalyst. Always true. When you introduce a catalyst, it lowers activation energy, hence the reaction becomes faster. Yeah. If you increase the concentration of H2O2, there will be more number of effective collisions per unit time. So again, the reaction will become faster. Yeah. So 1 and 2, definitely correct. Yeah. So with this, we can eliminate C, which only contains 2 and 3. Now, part 3, increasing pressure. Yeah. Thing is, increasing pressure will not have any effect in this reaction. Okay. So pressure only affects gas phase reactions. Let's just make a note here. So reactant is aqueous. So increasing pressure does not increase the concentration, or okay, doesn't increase the concentration. So rate is unchanged. So only 1 and 2 would be your answer, which is A. Now it's 26. Which species is an intermediate in the following reaction mechanism? So intermediate is a species which is formed in a step and which is used up in any subsequent step. Right. So in this case, CH3 whole twice C plus. This is formed in step 1 and it's used up in step 2. So of course, this is the intermediate. Answer is A. Next, what is the overall reaction order for this? We have the table, right? So first, when you're doubling the Cl2 concentration, you see 2.5 times 10 to the power minus 6 becomes 5 times 10 to the power minus 6. So this also got doubled. Yeah. I can say rate is directly proportional to the Cl2 concentration. Next, the Cl2 concentration again is same as the initial one. If I am doubling the NO concentration, what happens? 2.5 becomes 10 because 10 to the power minus 6 is same. So 2.5 times 4 is 10. So this, like, if you double NO, the rate becomes 4 times. So I can say rate is directly proportional to NO squared. Okay. Combine them together. Rate is K times NO squared Cl2. This is the rate expression. Order would be, just add up the powers, 2 plus 1, which is 3. This is the third order reaction. Next, what is true for rate constants for elementary reactions? Always increase with temperature? Yes. Whatever reaction it is, endothermic, exothermic, if you increase temperature, the reaction will become faster because of the Arrhenius relationship. Okay. The Arrhenius equation says that the rate constant always increases with increase in temperature. Okay. Yeah. That K equals A e to the power minus EA by RT, that equation, right? If you increase temperature, K will increase. So answer would be A. The next, the following system is at equilibrium. You have to find the value of equilibrium constant for the reverse reaction. For reverse reaction, we'll just do 1 by K. Okay. So 1 by 4.3, option C. Next, what is the effect of doubling the pressure on equilibrium? So when pressure is increased, so the equilibrium tries to reverse this effect. So equilibrium tries to the effect by shifting to the side with less moles of gas. So here you have 3 moles of gas on the reactant side, 2 moles of gas on the product side. As you're increasing temperature, equilibrium will shift to the side with less moles of gas. So equilibrium will shift to the right. So yes, you can eliminate B and D. Then effect of equilibrium constant K. So equilibrium constant K is only affected by temperature. Right? So here there is no change in temperature, only pressure is changed. So equilibrium constant remains unchanged. Answer is A. Next, what is required to convert a base into a conjugate acid? So a base needs an H plus ion to get converted to a conjugate acid. Because base is an H plus acceptor. So acid loses an H plus, becomes a conjugate base. Base accepts an H plus, becomes a conjugate acid. Right? So here, if you check the options, negative charge, hydrogen atom, electron paired, proton. H plus, if you analyze H plus, hydrogen has only one proton, one electron. If you remove the electron, you're just left with one proton. So H plus ion technically is a single proton. Okay, so base needs a proton to get converted to conjugate acid. Answer would be D. Yes. Next, which solution has a pH of 9? So pH is 9, so pOH will be 14 minus pH, so 14 minus 9, this is 5. So OH minus ion concentration would be 10 to the power of minus pOH, that is 10 to the power of minus 5. So we have to ensure that the OH minus concentration is 10 to the power minus 5, right? First one, 10 to the power minus 9 NH3. Of course, the OH minus concentration is very low. 10 to the power minus 9 NaOH. Again, it's very low. Okay. Now, 10 to the power minus 5 NaOH. I can eliminate this because NH3 is a weak base, right? So not 100% NH3 will dissociate. The concentration of OH minus will be lower than 10 to the power minus 5, right? Lastly, we have NaOH, 10 to the power minus 5 NaOH, which exactly matches with our requirements. The concentration is 10 to the power minus 5. NaOH is a strong base, so it will dissociate completely. OH minus ion concentration will also be equal to 10 to the power minus 5. So for question 32, the answer is D. Now for 33, explain why sulfuric acid has lower pH than methanoic acid of same concentration. Lower pH means it's a stronger acid, or you can say it has more H plus ion concentration. Now let's analyze the options. Sulfuric acid is diprotic while methanoic acid is monoprotic. Now this might sound logical, but it's not actually true because you also have H3PO4, phosphoric acid. Phosphoric acid has 3 hydrogens which it can ionize into, right? But phosphoric acid it's weaker than sulfuric acid. So the number of H plus ions is not really the answer. Okay, so A is incorrect. Next, sulfuric acid ionizes more than methanoic acid. This is absolutely correct because if sulfuric acid is ionizing more, there will be more H plus in the solution, right? As a result, the pH of sulfuric acid will be lower. Yeah. Let's also check the other two options. Sulfuric acid has a stronger conjugate base than methanoic acid. Wrong. If sulfuric acid has a stronger conjugate base, it has to be the weaker acid. Weak acids have strong conjugate bases, right? So the statement is incorrect. Sulfuric acid has a much weaker conjugate base compared to methanoic acid. Last, sulfuric acid is more soluble in water than methanoic acid. Solubility in water is okay, yeah, but ionization is important. So yeah, D is also incorrect. Next, which salt is basic? So we have to ionize all of them and check which one gives you a basic salt, right? So HCOONA, you can ionize it into HCO minus and Na plus. So Na plus comes from a strong base. It will not produce a conjugate acid or base, nothing. But HCO minus comes from HCOOH. HCOOH is the weak acid, so this is a conjugate base. While Na plus will be neutral because it comes from strong base. Next, HCOONH4 plus. HCO minus NH4 plus. So HCO minus is again a conjugate base. NH4 plus is NH3 with an H plus, forms a conjugate acid. So in option B, you have both conjugate base and conjugate acid. You cannot say whether it will be basic or acidic. For the first one, you can definitely say it will be basic because you just have conjugate base. Okay, so A is the answer, I'm pretty sure. But we'll also check the other options. C, NaNO3, Na plus and NO3 minus. Na plus comes from strong base NaOH, NO3 minus comes from strong acid HNO3. So here both are neutral. NH4 plus and Cl minus. NH4 plus is a conjugate acid, this thing. Cl minus is neutral. The conjugate acid and neutral will form a, of course, the acidic solution, right? The C and D are also incorrect. Next, what is the best indicator to use in the titration of phenylamine with nitric acid? Phenylamine with nitric acid, phenylamine is a weak base. Nitric acid is a weak acid. I mean, it's a very strong acid. Okay. So I'm pretty sure that pH at equivalence will be less than 7. And it won't be close to 7. It will be substantially smaller than 7 because nitric acid is a pretty strong acid. And phenylamine isn't really a strong base. It's a weak base, a pretty weak base. Right. Now we have to find the pH range for bromothianol blue. So what do we do for pH range? We do plus minus 1, right? If you minus 1 from pKa, you'll get the lower bound, right? And if you do plus 1, you get the higher bound. So this is the pH range for bromothiamol blue, right? So pH at equivalence should be in between 3.2 and 5.2. Then you can use bromothiamol blue. I mean, sorry, bromophenol blue, right? Bromothiamol blue has a pKa of 7. So pH range is in between 8 and 6. For phenol red, pH range will be 8.9 to 6.9. And phenolphthalein, pH range will be in between 10.6 and 8.6. Now, very easily you can eliminate C and D because C 6.9 is very close to 7. Right? We cannot use this. And we already know that pH is substantially smaller than 7. And option D obviously is giving you a basic pH range. Yeah. Now A or B. If you check A, 3.2 to 5.2, it's entirely acidic, right? B is 6 to 8. So 6 to 7 is the only acidic range for bromothiamol blue, right? But again, this is very close to neutrality. So I cannot reliably select B because nitric acid is a very strong acid. pH at equivalence will be small. Okay, it won't be close to neutral. So I will go with option A, and that's your answer with question 35. Now the next one. In which compound does sulfur have an oxidation state of +4? Okay, we can just analyze all of them. We'll take sulfur as X in each and every compound. So X plus hydrogen is +1. So 2 times +1. This is 0. From here, you'll get X as -2. But I need oxidation number of +4. So rejected. SO3. X plus 3 times -2 is 0. So X minus 6 is 0. So X is equal to +6. Rejected again. H2SO3. So 2 times 1 plus X plus 3 times -2 equals 0. This is basically X. If I simplify, I'll get X minus 4 as 0. So from here, X should be +4. So C is the answer to question 36. Also try the last one. 2 times 1 plus x plus 4 times minus 2 is 0. So if you simplify, you'll get x minus 6 as 0, which gives you x as plus 6. So D is also incorrect. Now next we have this cell potential. Yeah, we have this cell, right? So we have to find the standard electron potential E naught cell for this reaction. So one will be oxidized, one will be reduced, right? So we have to choose. So oxidation, I can choose the for the reduction part, we can choose the first reaction as it is because E naught is positive for the first reaction, right? But if we oxidize the second reaction, the E naught becomes plus 2.37. Now, when you add plus 2.37 to plus 0.8, you get a positive E naught cell, which makes the cell spontaneous, right? So for reduction, use the same Ag plus gives you Ag. For reduction, you choose the reverse reaction, Mg to Mg2 plus 2 electrons, okay? So E naught is 0.8, and then this E naught will be plus 2.37. So when you add these two, you just have to multiply this with 2. Fine. So twice Ag plus Mg gives you Mg2 plus twice Ag. So E naught becomes 2.37 plus 0.8, which is plus 3.17 volts. Answer is option D. Now moving on to question 38, right? So you have to identify which represents oxidation of functional group. So alcohol will be oxidized to form aldehyde or ketone, right? And if aldehyde is formed, it will be oxidized to form carboxylic acid. So this is the oxidation flow. Okay, this way it's oxidation, and the other way is reduction. Okay, so carboxylic acid to aldehyde is reduction. Yeah, so we can eliminate this. This is aldehyde to carboxylic acid. Okay, methanol to methanoic acid. So that is oxidation. So B is the correct answer for 38. Let's check the other options. This is alkyne, right? Alkyne to alkene. This is removal of oxygen. I mean, you know, addition of hydrogen, sorry. If hydrogen is added, that is reduction. Okay. If hydrogen is removed, that is oxidation. This is incorrect. And next one is aldehyde to alcohol. Aldehyde to alcohol obviously is reduction. So D is also incorrect. Now the next one. What are the products of electrolysis of dilute aqueous copper to sulfate while using inert electrodes, right? So copper to sulfate, when it's aqueous, we have to check for the competitions, right? So let's say these are the electrodes, right? These electrodes are connected to a power source. This is a positive terminal, this is a negative terminal. Okay. So towards the positive terminal, your negative ions will be attracted. So SO4 2 minus will be attracted here, H2 will be attracted, right? For the negative terminal, your Cu2 plus and H2 both will be attracted, right? Now for the positive terminal, there is no competition, right? Because SO4 2 minus is a complex ion. Yes. So basically, H2O will be converted to oxygen plus 4H plus 4 electrons, right? So this is oxidation. So at anode, oxygen gas will be produced, right? So this is the anode reaction. So the positive terminal is the anode, negative is the cathode, right? So we can eliminate option C, option D, right? Because at anode, oxygen is produced, O2, right? Now at cathode, there will be a competition, right? Competition will be in between these two reactions. Cu2 plus 2 electrons gives you Cu solid, right? And then water will absorb 2 electrons to form H2 and twice OH minus. You will get both the reactions from your data booklet. If you go down, lattice in the yeah. So this is our copper reaction, right? Then this is the H2O plus 2 electron reaction. And this is the reaction at the anode. That cathode will have these two reactions possibly. The other reaction, this one has an E naught value of, let's check, E naught value of minus 0.83. And here the E naught value would be copper plus 0.34. So E naught is bigger or more positive for Cu2 plus, right? So this reaction will be favored, right? And this one will not be favored because E naught is negative. So at the cathode, copper solid or copper metal will be produced. So answer would be option B. Now, moving on to the last question. So which equation represents propagation and radical substitution mechanism? Okay. So, all right, let's check. Now, initiation step would be Cl2 will break down into two chlorine free radicals. Okay. So option C is an initiation step, right? Another way of identifying initiation step would be you have more free radicals on the product side as compared to the reactant side. Yeah. Now propagation. This chlorine free radical formed will attack a methane molecule, which will basically take away hydrogen from methane and form the methyl free radical. This methyl free radical will attack a chlorine molecule, snatch away a chlorine, form CH3Cl, and it will form another chlorine free radical. And this reaction will keep going on. If you check, this first reaction exactly matches with the reaction here, right? So answer is option A. Now let's analyze the rest of the options. This one, option B, is a termination step because you have more free radicals on the reactant side as compared to the product side. So B can be rejected. And for the last one, okay, this is like, when you have multiple substitutions, right? So here the reaction goes like this actually. This chlorine will snatch away a hydrogen from CH3Cl. So it will form CH2Cl free radical plus HCl. Okay. So this is a propagation step, but the last reaction is incorrect because hydrogen free radicals are not formed. Okay, so I can also eliminate option D. So with this, we are done with this paper 1A. Thank you so much for watching the video. See you in the next one. Bye-bye.